Very good evening to everybody, those whose videos are on and those whose videos are off also. We are giving you 5 more minutes to make sure your video is on. Please always have your video on. This I said in the first class itself, that this class can be effective only if you are cooperative from that side, isn't it? There is a reason for keeping these classes. We are revising all the portions once again for you in a way that it helps you in the examination, isn't it? Apart from that, you are going to have test series also starting from this week. So I hope you know this, got a timetable, no? Every Saturday and every Sunday, you are going to have every week one science, one math, one science, one math, one science, one math. After 2 weeks, we will make it full mock test, 3 hours test you will have. For 2-3 weeks, we are going to have part wise, that is 2 hours test. And after that, we are going to make it full mock test where you are going to have 3 hours science, 3 hours of math every week. And then parallelly, Monday to Friday, this will keep on going, this will not change. And some of you may be wondering that why you are seeing me again. Monday already I came, once again I am coming on Wednesday, because timetable it shows math. Whenever math class is shown in timetable, I am coming. Is it not? It's not like that, there is some change in timetable. So that you will be seeing, I will be putting in the group. And hereafter I will come only on all the Wednesdays, right? So your bad luck or my bad luck, I don't know. Monday I came and Wednesday, so I have to come once again. Anyhow, we will learn some portions, and I hope whatever we learned in the last class, all of you were there. So the people whose videos is off, like Tarika, Shrina, Bhavin, Aditya, Soumya, Sukesh, Pratiksha, Sai Prasad, Mukesh, Sai Jiva, Ritika, Rishit, please guys, I am able to see you very clearly that your video is off, and if you are sent out of the group for not on the video, then you are the persons responsible. Don't ask me that why you removed me from the group. If they are going to drop you from the meeting, then it's because of your video not being on. Anybody has joined today who did not join in the previous class? Anybody has joined today who did not join in the previous class? Anybody is there like that? All of you were there in the previous class when I taught? I hope you were there. When I taught the light chapter in the previous class, I hope all of you were present. Anybody in the offline or online who was not there in the last class? I think nobody. Fine, very good then. Then today's class I will start with asking a few questions to you. Questions from where? Questions from what I have taught to you in the previous class. Okay? So today's class will start with a recall of the previous class. And when I say recall, if I take your name, please unmute yourself and speak to me. Don't be silent sitting there at your place, or don't leave the meeting in a hurry, in a fear dropping off the meeting. Don't do like that. If I take your name, be calm and then unmute yourself and speak to what questions I asked. If you are wrong also, there is no problem. You need not to worry about anything. Give a try. Okay. So the first question is for Ranjani. Ranjani, if you are able to hear me, please unmute yourself. Yes, you tell me that what is the meaning of principal axis? If I ask you what is principal axis, then what is your answer? Ranjani, if you are hearing me, okay, think. Define principal axis, I asked the question to you. The question goes to Nikhila. Nikhila, unmute yourself and say, I'll ask another question to you, Ranjani. You can revise the last class. Yes, Nikhila, please tell me, what is principal axis?
The line which passes through the center of curvature to meet the mirror at the pole.
Okay, good, very good. How many principal axes are possible of a glass? Spherical glass is there. How many principal axes can be made from that glass?
Sir, infinite.
Infinite, very good. So if I ask you that a ray is passing through center of curvature from the object, what will be its path after reflection?
It will reflect back to the same path.
It will retrace its path. What is the reason for that? Why it will retrace its path?
So it falls perpendicular on the mirror.
What is that called as? It has a name. That incidence has a name. I told in the last class. Anybody who remembers what is that incidence called as? Normal incidence. What is the meaning of normal incidence? When angle of incidence is 0 degree, that incidence is called as normal incidence, isn't it? So if I is equal to 0, R will also be 0. Good. Next question is for Soumya. Soumya, if you are able to hear me, please unmute yourself. The question is, if an object is placed between focus and center of curvature, then where will the image form? Object between F and C, where will the image form? Concave mirror. Soumya, I hope you are not saying anything. I have not heard anything from you. Are you speaking anything? No, I am not able to hear you. Please check your mic.
Sir, beyond C.
Beyond C. Okay, what will be its nature?
Sir, real and inverted.
Okay, what will be its size?
Enlarged.
Okay, good. Good, Soumya, good. So, next question is for Sudarshan. I hope you are able to hear me, Sudarshan. What happens if the object is placed at center of curvature in concave mirror? Center of curvature in concave mirror. Where will the image form? What will be its characteristics? Yes.
Image will form the center of curvature. The size will be same as the object.
Very good. And what will be its nature?
Real and inverted.
Real and inverted. Very good. Shrina, I hope you are able to hear me.
Yes, sir.
Yes, Shrina. You will tell me, if the object is placed at focus, where will the image form?
At infinity.
Very good. What will be its nature?
Real and inverted.
What will be its size? Size will be highly enlarged, isn't it? Yes, good. Navindran, I hope you are hearing. Yes, Navindran, if the object is placed between pole and focus of a concave mirror, where will the image form and what will be its nature?
Behind the mirror, sir, and it will be enlarged.
Virtual. Very good. Virtual, erect, enlarged inside the mirror, within the mirror. Very good. Yeah, very good. Next, the question is for Srinidhi, if you are hearing me.
Yes, sir.
Yes, the question is, if the object approaches from infinite to the focus in front of a concave mirror, where will the image approach?
From focus to infinite.
And what will happen to its size?
It will keep enlarging.
Good. Next question is for Vijay, if you are hearing me.
Yes, sir.
Yes, you tell me that what are the possible images formed by a concave mirror? Concave mirror can form what kind of images?
Sure.
Yes.
Real and inverted and virtual.
Erect. Okay, what about the size?
Highly magnified,
Good.
same,
Good.
diminish height.
Very good. Now, if I ask you, what image the concave mirror cannot form, what will be your answer? Which kind of image concave mirror cannot form? I'll ask you.
What?
Vijay, yes, please.
Yes, sir.
Which kind of image a concave mirror cannot form?
Yeah, I don't.
No issues. Bharat, tell me now. Virtual and diminished. Virtual and same size, isn't it? Can a concave mirror form virtual and same size? No. If it is virtual, it will be enlarged only. Am I right, Vijay? Concave mirror can form virtual image which are always enlarged. It cannot form any image which is which is enlarged or same size. So a concave mirror can form all kinds of images. It can form real diminished, real enlarged, real same size, real highly enlarged, real highly diminished. But virtual, it can form only one size, that is enlarged. Neither can it form the same size, nor it can form the, yes, same size and enlarged, diminished. It can form all the other kinds of images. Yes. So, Redmi Note 7 Pro, who is this? May I know your name? If not, then they will remove you from the group, man. Whoever is you, Redmi Note 7 Pro, what is your name? Okay. And still the video of Srihari, Ritika, Ramcharan, Jabikshan, Rishit is not on. I am not going to say it for the entire class that you have to on your video. I will instruct the people to remove you from the meeting. That's all I will do. Fine. Ramcharan, please on your video. Last class you came, I think, in person. Today you are from your home. You have your video must be on. Coming back. So next question is to Sanshita, who is sitting here in the offline class. Give me one application of concave mirror. Give me one application of concave mirror. Anyone? Loudly? Dentist mirror. Okay, she says that dentist will use concave mirror. My question will be, why? Okay, because they want to see some cavity, some small thing. So they will enlarge and see, so they are using the concave mirror. Okay. Now the question is to Sukesh. Sukesh, unmute yourself and tell me. It is true that dentists are using concave mirror for their application. They are seeing the cavity in the teeth. What is the object position when they are seeing the patient? Object is where for an enlarged image in concave mirror?
Sir, at focus.
Okay, very good. So he says object at focus, image will be highly enlarged. That is the best position, isn't it? Your name is Samiksha. Do you agree with what he says? So whether we should keep between F and P or at F, or between F and C, because all three are producing enlarged only. Why you are choosing F and P, or why you are choosing F? What you choose first of all? F and P, not F. Okay, he says highly magnified. Yeah, that is also good. No, big, very big you will get. What is the problem in that? At F, you agree with what Sukesh has told, not agreeing with your neighbor Samiksha. Okay, very good. Let us see the consequence of that. Okay, Vibhusha, what is your opinion? One of your friend here is saying image object will be at F, and one of her is saying object will be at between F and P. With whom you agree?
Between F and P.
Why? Why not at F?
At F is image will not be formed.
Image will not be formed.
Image will not be clear when we keep object at F.
Okay. If I keep the object between F and C, then also it will be enlarged, no?
Yes, sir.
Then why can't between F and C? Why only F and P?
F and P produces virtual image.
Why do we need virtual image? Got the answer? What she says is correct, Vibhusha is saying correct, but she is not able to explain it. Correct, Vibhusha, what you said? The object must be between P and F. You know why? Because if it is at F or it is between F and C, yes, we will get enlarged image, but real image. Real image can only be seen in screen. In your mouth, they will put one lens, that is one mirror. They have to put one screen also. How they are seeing the cavity, have you seen? If you go to doctor, dentist, he will have one, what to say, kind of a mirror which is attached to a rod. So he will put that in your mouth like this and see, okay, cavity is there. If he wants to form a real image and see, he should also have a screen in his hand. So in one hand, he should have a screen, put in your mouth and check where the image is forming. Impractical, right? Best thing is image forms inside the mirror itself. And that is possible only if the image is virtual image. So which object position? Between P and F. Got it? I hope you have got it. Next question is to Kanishk. Mr. Kanishk, unmute yourself. Yes. Somebody is asking something? If no, Kanishk, please tell me any other application of concave mirror. One was told by Sanskita as dentist. Very good. Second application. Any other application of concave mirror? This much time will not be given. Rudrapriya, what is your opinion? Rudrapriya. Any application of concave mirror? Any other application?
Sir, it can be used in torch to get powerful parallel rays.
Very good. She says that it can be used in torch to get a powerful ray. Now, in this case, where is the object, Rudrapriya?
Sir, it is between infinite and
Object is between infinite and center of curvature.
No, sir. It is at infinity.
If the object is at infinite, the image will form at focus. It will be highly diminished, isn't it?
I just changed the positions. It will be in focus, I think. Focus, and then the rays will be reflected in the infinite direction.
Why? Why we want that?
So then only we get parallel rays.
Good. When we use torch, can you tell me, Rudrapriya, where will the mirror be? In front of it or where it will be?
No ideas.
You know the answer. That's the problem. You are learning, but your concepts are still not clear. That's what worries me. Very good that you have told it is used in torch. I accept. Very good you told that it lies in the focus. But I don't know how many of you know that if this is a torch, okay? This kind of torch is there, no? Many of you think that this is the place where we are having concave mirror. No. Concave mirror is behind. That silvered thing is there, no? If it's nowadays torch, nobody is using. Mobile we have torch. But earlier torch we were having, this surface will be silvered. Have you seen it? Or one more better example I'll give you. Have you seen bike front headlight or car front headlight? There will be a bulb and behind the bulb there will be a silvered surface. Have you seen it? That silvered surface only is the mirror, and they will try to place the bulb at the focus. Because if the bulb is placed at the focus, whatever light is coming on it, wherever it hits, it will immediately become parallel. Why? Because that is a property. If any ray is passing through focus, after reflecting, it will become parallel to principal axis. Are you understanding? That is the principle of torch. I hope you are understanding this. Torch principle is, if the object is kept on focus, after reflection, the rays will become straight line. It will become parallel to principal axis. So we will get parallel strong beam of light. So if you say the application as torch, if you say the application as headlight, everything is same. Okay? Srinidhi, you have any other example? Any other application of concave mirror apart from these things?
I don't remember.
Don't remember? Okay, fine. Vinisha, what is your opinion? You have any other application of concave mirror?
Sir, the magnifying mirrors in the roads and things, sir.
Oh, yes, good. What she says is, on the roads, like when you go to hill stations, on the corners, they will have one big mirror. Have you seen? That mirror, she says, is a concave mirror. First of all, whether she is correct? No?
No, sir.
Those are convex lens.
Convex mirror.
Convex mirror. Okay. Well, I'll come back to you, Vinisha, the answer for this question. You good try, but
I'm having an example, sir.
please tell me, Mr. Ashwath, you are trying to say something?
Sir, I'm Sir Bhupesh.
Oh, Bhupesh, please tell me here.
Sir, lighthouse, sir.
Where are you first? I'm not able to see you. Lighthouse. Okay, lighthouse has a concave mirror, you say.
Yes, sir.
Okay, where it is present?
Actually, nearby beaches.
No, I'm not saying where the lighthouse present. I'm asking where is the light present?
Sir, same in focus only, sir.
Exactly. Fine. So even what example you are giving is the same example as torch. Correct. The lighthouse also will have concave mirror behind the big light, and that light will be at the focus. So whether you say the lighthouse or torch or headlamp, all these things are almost same category. I want some new category of application, if it is there. Shaving mirror, somebody said. Mukesh told, I think. Shaving mirror is correct, but shaving mirror is again is like dentist mirror. Dentist, what he will use for? Seeing the cavity. Shaving mirror is used for seeing some whether shaved properly or not. Nowadays nobody is seeing. Earlier we used to have a person who is shaving will have a mirror, he will see, okay, not did properly, do it once again. those things were there earlier. Now I don't think anybody is using concave mirror for seeing the shaving, but it is an application. Anything else? Solar furnace. Yes, tell me.
Vehicles headlight.
That's what I said now. Vehicles, headlight, torch, lighthouse, all of them are in same category. And somebody said solar cooker. Solar cooker also is a application where the cooker is placed at the focus. See, the difference between solar cooker and torch is, in the case of torch, the object is kept at the focus and the rays are produced by the object and it becomes parallel beam of light. But in the case of solar furnace, the object is kept, not object, the target is kept at focus and the rays are coming from sun, from infinite. They will focus at the, light will converge and pass through focus. There we will heat our food, whatever you want to cook it. So solar furnace or solar cooker, whatever you want to say, all these things, the object is at infinite, target is at focus. Okay. So whenever you are remembering any application of concave mirror or convex mirror, you should remember the application with respect to what is the object position, what is the image position. Randomly knowing may not help you because the question will come indirectly. Don't expect every time the question to come like, what are the applications of concave mirror? No, the question can come like, how a concave mirror helps a dentist to do dental surgeries, 2 mark. Then what you will write? If you just simply write something, they will not give marks. You should write, object is placed between pole and focus of the concave mirror such that the image is a virtual enlarged image. So he is able to see the cavities more clearly. These things you should write for 2 marks. I hope you are getting my point. Sometimes they won't ask question to you directly, they will ask indirectly. So you must know the application and also the application's conditions inside. Okay, fine. So with all these things, let us start today's class. I hope we could quickly revise whatever we learned in the last class, and we will start with where we left in the previous class, where we'll start with the image formation by a convex mirror, which we not saw in the previous class. So if you see a convex mirror and how is the image forming. So see, one thing about convex mirror is, convex mirror's pole, that is the focus and center of curvature, lies on the opaque side, am I right? This is what is called as a convex mirror, am I right? If it is visible to all of you, I will change the color if you want. So if you see here, I am going to have the focus, here I am going to have the center of curvature, and since this is the opaque side, the polished side, it is meaningless to say the object is kept on this side. Objects will not be kept on this side. Where will the object kept? Object will be kept anywhere in this range, isn't it? From infinite up to pole you can keep. But wherever you keep the object, you are going to get the same result. If the object is lying at infinite, then the image will form at the focus, virtual, erect, highly diminished. Other than that, wherever you keep the object, here, anywhere you keep the object, always the image will form diminished, virtual, erect, inside the mirror, between P and F. I hope you know this. All of you know about it. The same thing is going to happen in this slide also, where if they are going to place the object anywhere between infinite and pole, then you can understand that the image will always form something like this. The first ray goes, the second ray seeming to pass through center of curvature, and the object forms, the image forms at where? Between P and F. You can see it is meeting somewhere here. So the image will form between P and F inside the mirror. Understand that. So you can see yourself. Same like plane mirror. In plane mirror also, if you stand anywhere, you can see yourself. If convex mirror, wherever you stand, you can see yourself. The difference is, in plane mirror, whenever you see yourself, you will be in the same position as your image, or image will be in the same position as you. But in the case of convex mirror, it is not like that, because see, as I was saying you, the object can be placed anywhere in this range, isn't it? But the image can only form in the small range. Are you getting my point? In plane mirror, distance of the object from the pole and distance from image from the pole is always going to be same. Di is equal to Do. But not in the case of convex mirror. In convex mirror, the distance is huge here. Here can it have the same distance? No. The image can form only between what and what? Between pole and focus. One question has come in 12th standard, it may come in 10th standard also. The question has come like, a man is running in front of a plane mirror. He sees himself running in the mirror image. The same persons run with the same velocity in front of a convex mirror. Whether the speed of the image will be more than him, less than him, or same as him? Any idea? Same.
More than him.
More than him. Okay.
Yes.
Less. All answers. Very good, very good. All of you told the answer. Less than him. Less than him. Okay. So, now understand the logic of this thing. Logic is, the object has a huge distance, right, to cover, but the image has only very less distance to cover, right? Since image has very less distance to cover, it should run slowly, isn't it? If it runs in the same speed as the object, then it will be able, it should come soon to you. The range of the object is very huge. The range of the image is very less. So, if you run in front of a convex mirror, the image will be running slowly than you. The reason being, it can run only in a small range, where you can run in a bigger range. Are you getting my point? These things are not required for you, I am just telling you for your knowledge. Anyhow, so we come to know that the convex mirror, the image always forms inside the mirror, virtual, erect and diminished. So, if I proceed further, so the image position is mentioned, and it's virtual, obviously, erect and obviously diminished. So, where we use, this is what was told by somebody in the online, somebody told, yeah, Vinisha told that time. Vinisha, please check this, that convex mirror are used in this kind of scenarios. I think you talked about this kind of mirror only, not here, in hill stations I have seen it, and you can see in some near cameras also, in security cameras.
Yes, sir.
Underground parking also we can see this. Underground parkings, shopping malls, security cameras, in the turnings of the mountains, these things you can see. Because if you have a convex mirror, it has a large field view. Keyword, very important keyword. Since it has a large field view, it can cover a larger distance of see things behind it, isn't it? So, this helps in seeing a bigger thing. If you see here, if I would have put plane mirror, then I can see only the limited things. But since I am putting a convex mirror, I can see more number of things behind. So, we always use convex mirror in this kind of scenarios. So, if I proceed further, yes, what is this? Rear view mirror. Once again, in rear view mirror, which mirror we are using? Convex mirror. And why we are using convex mirror? The same answer. Large field view. Large field view means, suppose if I ask you, what if I put a plane mirror here? What is the problem?
We cannot see the
Entire road
distance
behind.
of the-
Exactly.
from far away places.
We can see far away, but we can see only the limited vehicles.
Limited.
Yes. What if I keep a concave mirror?
It always forms a real and inverted image.
We cannot see itself. Until it comes between pole and focus, we cannot see itself, because it is real image. We cannot see inside the mirror. We need a screen. That is impossible, isn't it? We will see only if it has come between P and F by the time it would have hit you. So, we don't use concave mirror in the rear view mirrors. Fine. So, the reason also is explained here. The reason is the large field view or the wide field view. If the question comes like this for 1 mark or 2 mark category, where they ask you reason for choosing a convex mirror for rear view mirrors, the word you should use must be this wide field of view or large field view. That is a keyword. See always board examination, keywords are very important. If you choose keyword only, they will give marks to you, because the correction happens by answer key. In answer key, they will give keywords, not the whole answer. So, keywords are very important. Coming back. So, after learning about this, let us quickly take some few very basic questions. Anybody who wants to answer can raise their hand from online, even here in the offline, and answer for this question. So question is, name a mirror that can give an erect and enlarged image of an object. Erect and enlarged. Srinidhi, yes please, I'll give chance to you next time.
Concave mirror.
Obviously concave mirror. Convex mirror cannot give. Plane cannot give. So only mirror that can give you an erect and enlarged image is concave. Where is the object? Between P and F. Yes, very good. So this is the question. Now, up to now we have seen about concave and convex mirror. Let us summarize the difference between them. So obviously you know very well about the first one, that is how it is being made. I told you, if you take a spherical glass and if you polish the inner side, it becomes a convex mirror. If you polish the outer side, it becomes a concave mirror, isn't it? That is the first thing given. And the second thing is, the concave mirror is converging the light falling on it, whereas the convex mirror, it diverges the light falling on it. And I said one more point to you, concave mirror has real focus, convex mirror has virtual focus. I said to you, concave mirror can form real as well as virtual image, whereas convex mirror can form only virtual image. What about plane mirror? Same like convex, only virtual, but same size, isn't it? So I hope you are very clear in concave and convex mirror basics, ray diagram and all. Today's class is mainly for mirrors formula, very important part where you lose marks, numericals. So I am going to enter into that part where we are going to talk about the mirrors formula. This question comes sometimes, that is if three mirrors are kept in front of you, plane, concave and convex, without touching it, how will you check which is a plane, which is a convex, which is a concave mirror? So what you should say? You should say that I will stand in front of it. If I am able to see myself enlarged, then I am standing in front of a concave mirror. If I am able to see myself diminished, it will be a convex mirror. If it is same size, it is a plane mirror, isn't it? This kind of question comes. How will you distinguish between a concave, convex and a plane mirror? So the answer is, if you are going to stand in front of the mirror and you are going to see yourself enlarged, then it must be a concave mirror. If you are going to see yourself diminished, it must be a convex mirror. And if you are going to see yourself same size, it must be a plane mirror. Also, convex mirror has a large field view, isn't it? Wide field view. So you can see a lot of things behind you in the convex mirror. Okay, coming to the next topic where we are going to talk about a sign convention, because without sign convention you cannot understand the mirrors formula. By now you may know this, but once again I am recalling it. That is, first you should keep in your mind that all the distances are measured from the pole, okay? And some of you have a thinking like object will always be on the left and the image will always be on the right. It's not like that. You may get a question where you may have a concave mirror like this. Why not? You may get. And where they will place, see, they will place the object somewhere like this. If you are remembering like right, left, you will confuse here. You should not remember like right, left. You should remember like how is the direction of incident ray. Always first thing in your mind, direction of incident ray will be positive direction, okay? And all the lengths measured against this direction will be taken as negative. That's all. So now, if this is the pole, this is focus and this is center of curvature. How do we define focal length? I told you, focal length is the distance of focus from the pole. This is focal length. How do you define center of curvature? Distance of center from the pole. It is center of curvature, called as radius of curvature, capital R. So you can see here, when I measure the focal length, I am going against the incident ray. Am I right? Incident ray direction was from right to left, but the direction of this focal length is from left to right. So can I say that this will be negative? Obviously negative. Can I say this will be negative? Obviously negative. Can I say object distance also as negative? Yes, it will also be negative. Basically for 10th standard, object distance will always be negative. How can it be positive? It will always be negative, because wherever you keep the objects, for example, if I am keeping like this, like this, towards the left side, if I keep the object, then the incident ray will be in this direction and your position will be again in the opposite direction. So once again you will become negative. I hope you are getting my point. If you are not getting my point, remember you will always be negative. Object distance for any mirror will always be negative, always. Now focal length, you can see for a concave mirror it is always negative because incident ray is like this, and if I take the focus and center of curvature, then the focal length is always measured against the direction of incident ray. So for the concave lens, the focal length will be always concave mirror. The focal length will be always negative. Do you agree with me? What about the focal length of convex mirror? Always positive. You know why? Because it is always measured in the same direction of incident ray. See, imagine here like this. There is object. Here is focus. Here is center of curvature. So the direction of incident ray is like this, from right to left, and we are also measuring focal length from right to left. So it will be positive. I am intentionally. You may think, sir, always I have drawn like this only. Why are you drawing and confusing me? I am intentionally confusing you because tomorrow in the exam, if you get the object towards right, you should not confuse. Your habit up to now is always keep object on left, image on the right if it forms. I don't think anybody is practicing by keeping object on the left, on the right. You always keep object on the left only. But don't, so your brain will think always object should be on the left, not like that. Object can be on the right also, depends on the mirror position. Okay. If this is a convex mirror, then if it is F and if it is C, this is the direction of incident ray and this is the direction of focal length. Both are same, so it will be always positive. So remember that focal length of convex mirror, positive. Focal length of concave mirror, negative. U of any mirror, concave or convex, always negative. What about V? Image distance. Depends upon the mirror. For concave mirror, it can be positive as well as negative because you know that images are formed on the same side of object also and inside the mirror also. So in one case it will be positive, rest everything will be negative. But V in the case of convex mirror will always be positive.
Always positive.
Always positive. So V for convex I am writing always positive. V of concave I am writing it can be positive or negative. These things you should know by now. I hope everybody knows this. I hope everybody knows this. The sign convention says that the distances must be measured along the direction of incident ray are positive. Any distance measured against the incident ray is taken as negative. Any height measured above the principal axis is positive. Any height measured below the principal axis is taken as negative. So positive, negative you should be very sure. So if the object is like this and the image is formed somewhere like this, then this will become negative, this will become positive, isn't it? So positive, negative is purely based upon directions. If it is upright, positive, it is inverted, negative, isn't it? And focal length of concave mirror, always negative. Focal length of convex mirror, always positive. U of both mirrors, always negative. V of convex mirror, always positive. V of concave mirror, positive in all the cases except one case where the object is between P and F, it will become negative. This story, whatever I have told now, should be always in your head. You should never ever forget it. You should never ever forget it. Always remember that which is positive, which is negative. And it is purely sign convention, need not to mug up also. Okay. So the same thing is given here. That is, Sir Descartes only found this sign convention. And if I talk about the convention that he told, same thing as I told you, that always you measure the distance from this is positive, if it is negative. See again, he took this as positive, this is negative. If I take ulta, it will become positive, it will become negative. Okay. So I am not going to go into this slide much, and I am directly going to enter into the numericals now. which is the mirror formula. What is the mirror formula, by the way? Any idea? 1 by
F is equal to 1 by V plus 1 by U.
1 by F is equal to 1 by V plus 1 by U. Very good. And what is the magnification formula? Height of the,
image by height of
Height
object.
of image by height of object.
very good. That is also always equal to,
minus V by U.
yes. So the first thing is 1 by V plus 1 by U is equal to 1 by F, and that is called as the mirror's formula. Next thing is magnification. What is the meaning of magnification? Magnification is the ratio of height of the image to height of the object. It is not like always V by U or minus V by U. What is the meaning of magnification? What is the ratio of the height of the image with respect to height of the object? That ratio is called as magnification, and magnification is always equal to Hi by Ho, which is also equal to minus V by U in the case of what? In the case of mirrors, because lenses it's not like that. In mirrors it is always equal to minus V by U, because in the case of lenses it will become equal to plus V by U. So yes, I am writing this wrongly written. It will be minus V by U. I hope it is clear. So magnification is minus V by U, and it is also Hi by Ho. You can write, you can remember like this also, Hi by Ho, height of the image by height of the object, and 1 by V plus 1 by U is equal to 1 by F is called as mirror's formula. For the people who are making mistakes in mirror formula, I would like to tell you that always have a habit of writing given in a numerical. When you are writing given, that time itself we put the value of known quantities with sign convention. I will repeat this. Whatever quantities are known to you, put those quantities with sign convention. And whatever quantities are unknown to you, don't put sign convention. I have seen children what they are doing. A question is there where they are asking you to find what is F. U and V are given. So they will write U as minus something, V as minus something, F as minus F. And they will solve, they will get wrong answer. Always remember, when you are solving a numerical, known quantities use sign convention. Unknown quantities don't use sign convention. Unknown quantities never use sign convention. It will automatically give you the answer in sign convention itself. If it is convex mirror, automatically focal length will come in negative only, positive only if it is convex mirror. If it is concave mirror, F will automatically come in negative if it is concave mirror. So your answer will itself give you in sign convention. Need not to put separately for that. It will be more clear when we take some numericals. So let us take couple of numericals today. All of you please be ready with your what? Notebooks and pencils, pen, whatever you are using. So with your notebook, start solving the numericals. The first numerical I am giving you is very basic one, and try to get the answer. Yes, the question is like this. Very basic question. Don't take more than 2 minutes. 2 minutes timer on, please. Zoom timer 2 minutes. Zoom timer 2 minutes. The question is, an object is placed at a distance of 36 centimeter from a concave mirror of focal length 12 centimeter. Find the image distance. Don't make any mistake in hurry. Solve patiently. 2 minutes is more than enough for this question.
Minus 18.
Minus 18. Okay, that is the answer.
So minus 18 centimeter.
Minus 18. Okay. Minus 18. Very good. Off the timer. Good, good, good. People have solved. So within 1 minute they solved, and it was simple question where they gave the value of U as how much? Minus 36. They gave the value of F as how much? minus 12, and they ask you to find what is the value of image. If you have time, always try to make a rough diagram in your notebook itself for numericals. Even though they have not asked, rough diagram if you make, it will be easy for you to solve the numericals. And when you solve this by keeping the u as minus 36, f as minus 12, see, this is the way you should write. Why I have presented this is the way, if you want to score 100 marks, this is the way of writing. Just simply if you are writing 1 by f is equal to 1 by v plus 1 by v and solving, they will not give marks. Always have a habit of writing given, to find, formula used, and then solution. If you are aiming for 100 marks, these steps are important, where you will mention all these things: given data, to find, formula used, and then you will solve the question. So, when you do that, you will get the answer, and when we have done that, we have got the answer as, like how you have solved, it will come as minus 18 centimeter, and the same answer has come, which is equal to minus 18 centimeter. This is the correct answer. So, it means that the image will be formed somewhere between C and F. Obviously, yes, because the object was kept beyond C. Since the object is kept beyond C, the image will form between C and F only, isn't it? Fine. So, go to the next question. Once again, 2-minute timer, please on. 2-minute timer, zoom. So, next question is here. At what distance from a concave mirror of focal length 10 cm should an object be placed so that the image is formed 20 cm behind the mirror? Make it fast, make it fast, make it fast. U is given. Not U is given, you have to find U. F is given and V is given.
Sir, timer is hiding the.
Timer is hiding. Okay, you can off the timer, or we can change the location of timer. You can do one thing. Once again, down the timer, show timer to all. Yes, remove that, and then put timer. Yes, tell me. Anybody asking something?
Is the answer minus 10 centimeter?
I don't know. I will see after this. Minus 10 is the answer given by Ashwath. Anybody else? Anybody else? Solve fast. Minus 10 is Ashwath's answer. Others, please check your answer. It may be right, it may be wrong also. Minus 10 only. Okay, some other answer. Check your answer, Ashwath. In a hurry, you should not say wrong answer.
Minus 20.
Minus
10 by
20.
3.
10 by 3. Guys, don't be like this. Be patient.
6.67 approximately.
That you are getting. Okay, you are getting 20. Okay.
Minus 20 by 3.
Minus 20 by 3.
Minus 20 by 3. That sounds correct. Okay. What about Ashwath? No hurry, man. Answer correctly. Hurry is not required. You should answer correctly. So, if you see, first of all, they are giving the value of what, man?
The answer is 20 by 3. I mean minus 20 by 3.
You told 20 minus 20 by 3.
Yeah.
Yeah means what? Now only you are saying, man. First you told something else. 10 he told. Minus 10.
Yeah, that's.
Yeah, man, wrong is wrong. You cannot change your answer again and again. Anyhow, so focal length is given as minus 10, V is given as plus 20. You want to find U, and the formula is 1 by V plus 1 by U is equal to 1 by F. And when you solve it by putting the values, you will get the answer of U as, just by proper solving, you will get the value of U as minus 20 by 3, and that is equal to minus 6.67 centimeter. Once again, when you get the answer, you should think, man. Ashwath, you told 10 centimeter instantly. Think here. Focal length is 10. If the object is at 10, then the image will form at infinite. Isn't it, Mr. Ashwath? Some people told 20. Think again, Samiksha. If you say 20, then the image should form at 20. Object at 20, image will also form at 20. No, because 10 is the focal length. 20 will become a center of curvature point. So, before saying the answer, think once again that whether it is possible or not. Coming back. Third question. Make it fast. Next question. 2 minutes timer. Fast. Very similar, simple question. Object placed 20 centimeter in front of convex mirror. Convex mirror, be careful. U is given, and they are giving the value of V to you, and they are asking you to find the value of F. Fast, 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 but don't do mistake in doing fast. Give a try. Don't do any mistake.
Sir, 60 M.
60 by 60 by 7 is the answer by some people. Is it by everybody?
No, sir, just 60 centimeters. Sir, F equal to plus 60 M, sir.
Plus 60.
Sir, 60, sir.
60, sir.
Plus 60.
60 centimeter.
Okay. Let us see. So this is the condition given. They have given the value of U minus 20. They have given the value of F V plus 15. They are asking to find the value of F. When you put all the formula, then when you solve it, you will get the answer of F as obviously 60 plus 60. Correct. Good. Next question is a different type of question. I'll not give this question. I'll give some other question. Okay. Not this question. Let us change the variety of question. Yes. Yes. So, now the question is, object 4 centimeter in height is placed at a distance of 36 centimeter from concave mirror. The image is formed 18 centimeter in front of the mirror. Find the height of the image. Solve fast. 2 minutes timer on. 2 minutes timer on. Height of object is given, U is given, image distance is given, height of image is required to be found. Minus, okay, one answer. Minus 2 is the answer by Bharat, minus 8 is the answer by whom?
Minus 2 centimeter.
Oh, minus 2 some people are saying. Minus 2. Anybody else? Answers are coming inside as minus 2.
Sir, 2, sir.
Plus 2 or minus 2, Bhupesh?
Plus 2, sir.
Oh, he says plus 2. Plus 2 is possible. Check, no man. Concave mirror, object 4 centimeter. Can you have plus 2? Can a concave mirror produce work?
Minus 2, sir.
Sir, minus 2.
Think. Minus 2. Can I log the answer minus 2? Okay. So if you see what is given, HO is given as 4, U is given as minus 36, image minus 18. They have asked to find the value of H2. When you put in the formula, you are going to get as minus 2 centimeter. Correct. Good. Next question. Next question. Again 2 minutes timer. Fast. Converging mirror forms a real image of height 4 centimeter of an object of height 1 centimeter placed 20 centimeter away from the mirror. Find the image distance. 80. Okay. 80 is the answer by Sanchita. Anybody else? 80 is one answer that I have got. 80. Good. Anybody else?
80, sir.
80. Good. 80 is coming. Anything else apart from 80? Ashwath, what do you think?
Sir.
80. Okay.
Yes, sir. 80.
So real image, it means it will be inverted.
80, sir.
So they have given you the value of U. They have given you the value of they have given the value of V and they are given the value of hi. They are asking for v. Okay. So if you see, everything is given, and image distance they are asking to find. When you solve by putting the hi by ho is equal to minus v by u, you are going to get the value of v as minus 80 centimeter. Good. Minus is important, just 80 is not going to work out. Okay, fine. Next question. Yes. Yes. Yeah, that is a mistake in typing, but actually it shows minus 80 only is the answer, right? Okay, fine. So just do the first part of this question. Second part you can do it later. First part is a concave mirror produces 3 times enlarged image of an object placed at 10 centimeter in front of it. Calculate the focal length of the mirror. Concave mirror produces 3 times enlarged image of an object placed at 10 centimeter in front of it. Think, solve fast. They are asking you to calculate the focal length of the mirror. They are asking you to find f, and what they have given to you is the height of the image and height of the object ratio they have given. hi by ho is given as 3, isn't it?
Sir, focal length minus 15.
Minus 15 is our answer by Srinidhi. Anybody else? Anybody else? Any other answer? Minus 15 is the answer. Anybody else with any other answer?
Sir, minus 50.
Minus 50.
15, sir.
15. Okay, minus 15. One more answer has come, minus 15. Anybody else? Minus 7.5 is the answer. Please check what mistake you have done, because magnification is minus v by u, and they have told a concave mirror. If concave mirror produces the image 3 times enlarged of an object placed 10 centimeter in front of it, calculate the focal length. So actually this question can be solved in 2 ways. Don't you think so? This question can be solved in 2 ways. If I solve this question, there will be 2 parts. One part is when m is equal to plus 3, and one part is when m is equal to minus 3, isn't it? Because they are saying enlarged, it can be real enlarged, it can also be virtual enlarged. Both possibilities are there, isn't it? So what they have told here is only one part of the answer. If this question comes, yes,
I took the magnification as plus 3.
then you will get the answer. Both are correct. If this kind of question comes, then you should solve both the parts, that is when m is equal to plus 3 and when m is equal to minus 3. If you solve any one part, they will give half marks. If it is 3 mark question, they will give you only 1.5 marks. If it is a 3 mark question, they will give you only 1.5 marks if you solve and get the answer of only one part. Like in this thing, they have solved only one part, m is equal to minus 3. But you have solved m is equal to plus 3, Srinidhi. So she has got 15 centimeter. Both are right. Minus 15 also is correct, minus 75 also is correct. But you should solve both and show it. If m is equal to plus 3, then you will get v minus v by u is equal to plus 3 and solve. And here minus v by u is equal to minus 3, and then you will solve. In both the cases, when you solve, you will be able to get the correct answer. Are you getting my point? So whenever you get a numerical where you have just magnification mentioned, not mentioned real or virtual, then solve both the cases for getting the correct answer. It will have 2 answers, 2 possibilities. Okay. So fine guys, we have come to the end of today's class. Next class we will start talking about refraction lenses, and I will share a worksheet with you which has the questions of mirrors and mirror formula for practice. The more you solve numericals, the more strong you become, and expect question to come in the board examination from mirrors formula. At least one question will come from the numerical from here. So practice it well, and light has the maximum weightage in the board examination. In physics, not physics, whole science, which chapter has maximum weightage? is light. So it's an important chapter. Please take it seriously. Practice more numericals from mirrors formula and magnification. Okay. Next class will continue. Till then, take care. Bye bye. We'll meet again on next Wednesday at same 6 p.m. Bye bye. Take care.